Oh. Okay. Any questions on the homework or anything what we're doing? Questions? Okay. So we're going to change the homework handing in thing because it's kind of a hassle, I guess, to find the boxes. So from now on, we'll just try handing the homework in section. Okay? Is that better? Yeah. Okay. So we'll just hand it in a section when you see your TA. So that's probably also skip. It's more direct. That makes sense. So we just when you see your TA section, it's just hand in your homework. Okay. Any questions on the homework? Yeah. Yeah. Yeah, you should. Yeah. So it's just easier for them to grade it if it's in hard copy than if it's that way they don't have to download it and all that stuff. So so just talk to your TA, make sure that you can tell them that you uploaded it and all that, but make sure they have hard copies. Yeah. Any questions? Okay. Okay. So let's pick up where we were last time. So let's take a look at this game. We did that penalty kick example. Remember, what was the whole point of that penalty example? Is there a pure Nash equilibrium in a penalty kick? No, right? It's kind of like the cyclical thing. Like if I go east, you want to go west, and if you go west, I want to go west, and blah, 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 kind of this whole thing. So similarly, we look at this game. So let's take a look at this one. Is there a Nash equilibrium in this game? So 2 does A, what's 1's best response? The 4, right? If 2 plays B, what's 1's best response? The 6, right? That's why I underlined the 4 and the 6. Is that clear? If 1 plays A, what's 2's best response? The 3, so I underline the 3. 1 plays B, 2's best response is the 7. Is there anything which has both other ones? No, so there's no pure strategy Nash equilibrium. Right? The definition of a pure strategy Nash equilibrium is a situation in which everyone's best response to what everyone else is doing. In this case, there's no mutual best response, right? If 1 plays A, 2's best response is to play B. If 2 plays B, the 1's best response is to play B. If 1 plays B, 2's best response is to play A. If 2 plays A, 1's best response is to play A, etc. Okay? There's no stability. From every point, somebody wants to do that. So then what do we say we need to do? Mix, or we need to consider probabilistic actions, just like in the penalty case. Okay, so there's no pure strategy Nash equilibrium. Let's do mixed strategies. Okay, so we did the one with the penalty kick. Then it just worked out great to be half-half both sides, right? So this is a case probably not going to be half-half because the numbers are kind of a little arbitrary. Okay, so they're different. Let's see. So how am I going to do this? Okay, so the way to do this is first I put the p in 1 minus p. What does this mean? I'm going to keep my little variable. First of 1 plays A would probably be p, and B would probably 1 minus p. Why do these numbers add up to 1? Those are probabilities, yeah. Probabilities have to add up to 1. So for example, if I play A would probably 1/3, I have to play B would probably what? 2/3. I'm going to put my Q and 1 minus Q up there. Q will play A would probably Q, B would probably 1 minus Q. So we're going to try to figure out which P and Q correspond to a mixed strategy Nash equilibrium. Okay. So I think what we did is this little, let me write down the beginning of the so we have 1A. What's going on with my markers? I brought two, literally brought two just today. You can't see that, right? You probably can't see that at all, right?
I think there's some on the other side.
I literally just blocked. Okay, I'll just solve. This makes me mad. Let's see this works. I think it's the board, right? Okay. Let's do black. Okay, so one is either A or B. A is probably B. One is probably minus B. Okay. And then two is either A or B. Probably Q. This is probably the minus Q. What's my game? 4, 0, 6. Zero, 3, 7, 6. Okay, so we're going to make our little box thing, okay? So I did that. Let's make a box. So our box could look like this. Okay. So this corresponds to P equals 1 up here. P equals 0. Okay. So this, the way you think about it is, it's kind of like this, right? So this is the upper left-hand corner. This corresponds to the upper left-hand corner of this. Does that make sense? Yeah. Okay. And then this is Q equals 1 on this side. Q equals 0 on this side. Okay. All right. So how do I find the Nash equilibrium? How did we do it last time with the penalty kick case? You remember it? Huh? Yeah, I gotta find the switchover points, right? I gotta do the stars and pluses, yeah? Okay, so how does that work? Let's see. Okay. No. Let's do it. First, what you're gonna do is go stars, so there's person 1s. This should be in red, that's green. If person 2 plays Q equals 1, that is playing A all the time, what is 1 going to do? 4, right? 4 is better than 1. So 1 can choose any one here, and the best one is the 4. Yeah? Okay, so I'm going to put on a star there. Okay, so I think that's what 2. What if 2 plays this? That means Q equals 0. That means person 2 is playing B all the time, right? Q equals 0, this is 1, yeah? Okay, if 2 plays B all the time, what is 1 going to do? I think, well, 6, right? Which is playing B, yeah? So that corresponds to down here. Yes? Okay, did I do that? Yeah. I think that's what I have. Okay, what if Q equals 99.99? That is almost, so person 2 is playing A almost all the time. What is 1 going to do? A, right? Okay, what if Q is 0.01? That is, person 2 is playing B almost all the time? B. Okay, so we have this whole little thing just like we did before. The interesting thing is, when does Q switch over, right? When does 1 switch over from this to this? See what I'm saying? Right? So if 2 plays A all the time, then Q is close to 1, person 1 will play this, A. If Q is 0 or close to 0, that is 2 plays B most of the time, person 1 will play B. Okay. At what point, at what Q does person 1 switch over from playing A to B? Yeah. Okay. Okay, so we're going to figure that out. Let's do some math here. So what we do is we do this expected utility calculation, expected value calculation. I guess I'll use NPV. So this is person 1's expected utility or expected value from playing 1A. Okay. If person 1 plays 1A, let me see. If person 1 plays A, 1 is getting what? Sometimes the 4 and sometimes the 0, right? Yeah? You see that? Okay, so sometimes a 4 and sometimes a 0. Okay? With what probability is person 1 getting the 4? Q, right? Person 1 gets a 4 if person 2 is playing A. 2 plays A, probably Q. Okay? So it's going to be 4 times Q. Remember, the expected value is your payoff of something times the probability of that something, right? Added up over all things. Okay. So person 1 could get the 4 with probability Q. Person 1 could get the 0 with probability what? 1 minus Q. Okay, that's person 1's expected value. Okay. So if I do some math on this to simplify this, what do I get? Well, this is 0, right? This is 4. What's the expected value in that person 1 playing B? Okay, if person 1 plays B, person 1 gets either a what? 1 or a 6, yeah? Right? Person 1 gets that 1 with probability what? Q, right? Person 1 gets that 1 if person 2 were to play A. He gets that 6 with probability what? 1 minus Q. Okay, if I do a little math on this, what is this? This is going to be Q plus 6 minus 6Q, right? Is that right? This is the first time I'm actually doing something like, which looks like algebra for this class. And this becomes what? There you go. Negative 5Q plus 6, so let's do 6 minus 5Q. Okay? Make sense? So we can also do what we did before mathematically. Q is 1, which is the bigger number? That one or that one? Q is 1. Is the bigger number A or B? This is 4, this is 1, yes? So if Q equals 1, person 1 should choose A. It is up there. If Q is 0, which is the bigger number, A or B? This is 0, and that's what? 6, right? So the bigger number is B. So if Q is 0, person 1 should pay down there. Does that make sense? Okay. What if Q is 0.9? This number is like what? 3.6, yeah? This number is like 1 point something, yeah? Right? Make sense? 1 point something. So which is number? Q is 0.9, which is bigger, the A or B? A, right? So if Q is 0.9, we're gonna still put that little A thing up here. Yeah? What if Q is 0.1? Which is bigger, A or B? B, right? Because that's 0.4, that's gonna be like 31.5, yeah? Okay, so that's, so we do this. Okay. All right. What if Q is like 0.3? This is 1.2, this is gonna be, still B is, sorry, Q is 0.3, right? Hold on, let me do this. Yeah, Q is 0.3, this is 1.2, this is like what? 4 something, yeah? So Q is 0.3, have this. What if Q is 0.6? Would you imagine? Let's think of it this way. Am I on? I have a low battery situation. Let me see if you can fix this. Can you hear me okay though? Yeah. Okay, let's just go. We'll do the unplugged version. Okay. If Q is, let's see, so if Q is 1, which is bigger, A or B? This is 4, this is 1, yes? This is bigger. If Q is 0.9, which is bigger, A or B? A. Q is 0.8, which is bigger, A. Q is 0.7, which is bigger, A. However, if Q gets too low, then B will be bigger, yes? Yes. At what point do we switch over from A to B? 2/3. How do you know it's 2/3? Yeah, exactly. You see what I'm saying, right? So when Q is 1, this number is bigger than this. Q is 0.9, this number is bigger than this. But at some point, this becomes bigger. The point it becomes bigger is exactly when what? These things are equal. Does that make sense? As Q becomes like goes from 1, 0.9, 0.8, this gets a little smaller, it's a little bigger, and at some point they'll be equal. Yeah? And that's the point where it switches over. Yeah? That's why I find the point of the switchover probability. Okay, so switchover probability. Okay. To find the switchover probability, I set those two things equal. Okay, does this make sense? This makes sense why? Okay, so now what Q makes this equal? How do I do that? I just solve for it. Yeah, I just do a little math. Okay, so I add 5Q to both sides, I get 9Q equals 6. Okay, so therefore Q equals 6 over 9 equals 2 points. Does that make sense? Okay, so let's do that. Let's see what I have over here. Okay, I did kind of the same thing. What's a switchover? Okay. How do we do that? Okay, what's a switchover for Q for person 1? Okay, remember, I'm just reviewing. Remember, 2 plays A with probability Q, B with probability 1 minus Q. If 1 plays A, he gets expected payoff 4Q plus 0, that's this. Okay. If 1 plays B, he gets expected payoff this. Okay. The switchover, so Q is close to 1, this is bigger than this. Q is close to 0, this is bigger than this. The switchover is exactly when those two things are equal, right? When does one switch over? When 4Q equals 6 minus 2. That's the switchover problem. And I can solve for those things. I get Q equals 2/3. Make sense? Okay. So going back to my picture, when Q equals 2/3, this is the picture I have. This is my stars, and I guess I should explain this too. When Q equals 2/3, person 1 switches from playing A to B. When Q equals 2/3, which is the best response for person 1? Okay, either of them, right? Plus what? So the person, because they're equal, right? So when Q goes 2/3, either, whoops. Either A or B, they're exactly the same, right? So this is the best response, and this is the best response also. Plus, what else is the best response? Everything in between, yeah? Because if I get the same thing from A and B, then I'll get the same thing from any randomized mix between A and B. Yes? Make sense? Okay, so I'll always. Does this make sense? That's what one's best response is. Yeah? Okay, let's see what I did here. Yeah, I solved Q equals 2/3. Yeah, those are my pictures. Make sense? Okay, all right, so we already did half the problem. Kind of half done already. Okay. Let's look at 2's best response, the pluses. Okay, let's do again the simplification. If 1 were to play A, that is P equals 1, what is 2 choosing among? The 0 and the 3, right? Which is the best response for 2? Playing B, yeah? If 1 plays A, 2 will play B. B and get the 3. Okay. So I should put the little plus over here. Okay, so what I have up there? If 1 plays B all the time, that is P equals 0, so this is a 1. If 1 plays B all the time, what should 2 play? 7. The 7, which corresponds to playing A. Yeah? That corresponds to this. Person 2 is choosing anything in here. This is the best one. Okay. What if P is 0.99? What should 2 choose? B or A? B, right? P is 0.9, that is person 1's playing this almost all the time. Person 2 should play the B. If P is 0.1, that is person 1's playing B almost all the time. 2 should do what? A, right? Okay. And so we have this kind of thing. The only thing is at what point there's a switch over, right? Make sense? Okay. So I have these pictures here. Hey, where's the switch over there? Okay. How do I figure that out? Okay, so let's kind of do something similar over here. Okay, we're looking at now the expected value for a person playing 2A and 2B. All right, if person 2 plays A, she's getting what? 0 or 7, right? With what probability is she getting the 0? P. And what probability she's getting 7? 1 minus P. So it's 0 times P plus 7 times 1. This is going to be what? 7 minus 7. What if person 2 plays B? They're getting what? 3 with probability P, and 2 with what probability? 1 minus P. So it's 3 times P. And then 2 times 1. So if I do some math, this is what? 3P plus 2 minus 2P is 3. Okay, let's do the same thing again. If P is, did I make a mistake? Oh yeah, thank you. Okay, if P is 0, which is bigger? A or B? P is 0. That's 7 and that's 2, yeah? P is 0, this is bigger, right? That corresponds to P is 0. Person 2 is going to play A, right? That's what the plus is. See that? Right? If P is 1, which is bigger, A or B? B, right? This is 0, that's 3, right? So P equals 1, person 2 can choose anything in here and plays B. That's what the plus is there. Yeah? Okay, let's do the same thing. P equals 1, B is better than A. Yeah? Okay. P equals 0.99, B is better than A. P equals 0.9, I still think B is better than A. Okay, P equals 0.8, 0.7, 0.6, 0.5. At some point, then person 2 is going to switch over to playing A. Two is going to switch from playing B to A. Make sense? At what point does 2 switch over? Huh? Exactly. They switch over exactly when it's equal, right? Okay, so this is the switch over thing again. I simply set those things equal. Seven minus 7P. Okay, and then I can do some math. This becomes like 5 equals 8P. 8P equals 5. Okay, makes sense? If P equals 5/8, then these expected values are. Let's go over here. When P equals 5/8, person 2 is exactly indifferent from playing A and B. The expected values are the same. So this is the best response, this is the best response, plus what? Everything between it. What's my Nash equilibrium? Yeah, where they intersect, so it's this. Yeah, that's a mixed strategy. Okay, this is the Nash equilibrium. Any questions about that?
Will the graph be with that?
Huh?
Will the graph be with that?
No, that's a short answer. So, there's a reason I'm doing all this graph stuff, which is to simply show that this is, all we're doing is we're finding regular Nash equilibrium of a game where we include all the mixed strategies, okay? But you don't have to do this all the time because it's just faster. You don't have to do this. All right, but let's just see. Okay, this is what I'm reviewing. If person 2 plays A, their expected utility is 7 minus 7P. By playing B, expected utility is 2 plus P. You set them equal. Okay, that's the equal thing. And you do the math thing. You can P equals 5. Yeah?
That means that the Nash equilibrium is 5/8 of P plus 3/8 of
Yeah, it's okay. Yeah, so let's well, how do you write down the answer? Okay, so this is just a picture. So how do I write that down? Well, it's the sideways there. What it is after you figure out this stuff, you just stick it back in here, right? So P equals 5/8, so this is 5/8, yeah? 5/8. And then 1 minus P is what? 3/8, right? 1 minus 5/8 is 3/8. Q is what? 2/3, right? So this is just 2/3. And this is what? 1/3, right? 1 minus 2/3. So the best way to write down the Nash equilibrium is to write it this way. The Nash equilibrium is 1 place 1A with probability 5/8, right? And 1B with probability 3/8. And then 2 plays 2A with probability 2/3. 2B with probability 1/3. Okay, that's the best way to do it.
So the Nash equilibrium with like mixed strategy isn't necessarily like a certain situation, it's just the probability of what they're gonna play.
Exactly.
Okay.
So it's kind of a different, it's not a great prediction in some sense, right?
Yeah.
What we're just predicting is like, we don't know whether it's going to do A or B, but we think they're going to play A with probably 5/8. So in some ways it's not satisfactory, right? Because you can't disprove it, right? But it does sort of make sense that they're doing an example, right? It does sort of make sense that in the penalty case, no one's going to do 50, sorry, no one's going to do 60/40, right? There's a pretty clear reason why you do 50/50. So this, yeah. But
Is there a way, like if there was like a pure strategy Nash equilibrium, that you could find the mixed strategy
yeah, so,
equilibriums and that would be different than?
yes, that is possible.
Okay.
It would do exactly. Yeah.
Couldn't you also write the Nash equilibrium though without the words by just saying like 5/8 1A plus 3/8 1B? Are we allowed to do that too?
So, okay, so,
Because that's how I saw it in section.
okay, so I'll tell you what would be wrong and what would be right. Okay, so what would not be good is to write. Okay, if I simply wrote that, that would not be, I would count that as wrong. Okay, the reason is because I could have, like, going back to the very beginning, like, I could have done it this way, right? It was just arbitrary. I could have did 1 minus P here and P here, yes? Right, I could have done it that way. That would not have been wrong. If I'd done it this way, I would get a different P from you. Right? I would get a different P. I would get P equals 3/8 instead of 5/8. You see what I'm saying? Right? But once, if I solve for it and then I wrote it like this, I would get the right answer. You see what I'm saying? So by doing this, you're inviting arbitrariness. That's all I'm saying. So this is not sufficient because it's not telling me what somebody's doing with what probability. Is that clear, what? Yeah, so don't do this. This is not sufficient. Because, however, sometimes people do abbreviate and they say this kind of thing. They say like 5/8 1A, 3/8 1B, something like this. This means kind of you plate 1A with probably 5/8, 1B with probably 3/8. Okay. Do you see what I'm doing here? So this is kind of like saying I'm playing 1A with probably 5/8, 1B with probably 3/8, 2A with probably 2/3, and 2B with probably 1/3. Some people write this down because it's a lot easier than doing this. Okay. I kind of don't like this that much because this is not really a mathematical expression, right? You see what I'm saying? This is a strategy. This is not an algebraic thing. This is not like X or P or Q or something. You see what I'm saying? But this is okay. This is fine. This is what you did in section? Yeah, this is totally okay. Okay, so this is okay because you see why, right? Because it at least clearly says what somebody's doing with what probability. Yeah.
So on the homework on number 9C, it says write down a sentence of strategies and play with what probability.
Right.
So would you take that equation?
I would rather see this.
Okay.
Yeah, but this is okay too. Yeah, but by sentence, that just means you just have to clearly indicate what probability is, what probability everybody, what people are doing with what probability. Just clearly indicate that. That's all, right? And all I want to say is that okay, this doesn't do that, right? Just to be clear, this doesn't
It says
indicate.
not to do that.
Don't do this. Yeah,
Okay.
don't do this. Do not do that because it doesn't clearly state what's going on, right? And also by doing it this way, you're kind of inviting. You're basically like if if you put your p and 1 minus p differently than I did, then you'll get it wrong. You see what I'm saying? So as long as you put it back into this, you'll get it right. You see what I'm saying? So just don't do this. That's all I'm asking for. Just clearly indicate what everyone's doing about probability. That's all. Yeah.
Is that to say, like, in a game like this, player one would play a, like, 5 at 8 times?
Right. That's what it says, yeah. So we solve for, well, let me bring it down. We solve for P, we're saying, yeah, the prediction is that person 1 will play A, probably 5/8. 5/8 at a time will play A. Any questions? So yeah, so I wrote it as a sentence on the sideways up there. Okay. But if you do it this way, that way's okay too. I guess it's a little faster. Any questions? Okay, so somebody asked, so anyway, so this is just the sum up slide. Are there any pure, this is okay, are there any pure strategy Nash equilibria here? No, right? Okay. I can put my P and my Q's back in there. This is what I get. This is the answer. Okay, as a sentence. Because Lucy clearly states what each person does. Finish. If you really want me to do that. For the record, you can also, right, 5/8, 1/8 plus, is that how you did it? 3/8, 1A, 1B. Uh, 2/3, 2A plus 1/3. Okay. Okay. Yeah. What do you mean calculate it? Sorry? What do you mean? What's the question? This is not a meaningful mathematical expression, just to be clear. Yeah, this is just a way of notating, right? 1A is not a variable. That's this plus, again, that doesn't mean anything really either. That's why I kind of don't like this. This simply means play 1A with probably 5/8, play 1B with probably 3/8. What does a plus mean? It doesn't really mean anything. Okay, so that's why I kind of don't like this. It's kind of like an abusive notation. Okay, this is really better, yeah, because it's clearly stating what you're doing. But this is not wrong. People do this all the time. Okay? That's what I'm saying. But exactly, when I write this thing, what's a plus? So that's a kind of, yeah. Okay, anyway, does it make sense? Okay, all right. Okay, that's good. Oh, somebody asked, is it possible, like you'll find a game with pure strategy Nash equilibrium, but also has mixed strategy Nash equilibrium, right? So, like the penalty kick case, there was no pure strategy Nash equilibrium, so I had to find a mixed strategy. And this one we just did, there was also no pure strategy Nash equilibrium, so we had to find a mixed one. Okay. What about this game? Are there pure strategy Nash equilibrium? Let's do it. Let's do the underlines. We did this game before. Do you remember the name of this? Oh, it's Battle of the Sexes. I put it up there. In 2 plays prize A, what's one's best response? 2 the under, yeah. If 2 plays opera, one's best response is opera, right? 1's better than 0. If 1 does prize fight, 2's best response is prize fight. If 1 does opera, 2's best response is opera. Okay. So, do I have any pure Nash equilibria? Yes, I have 2 of them, in fact. Okay. They both go to the prize fight, or they both go to the opera. Okay. Is there a mixed strategy Nash equilibrium? Okay. Well, what do you think? Yeah, we can calculate. Well, let's see what happens. Okay, so we'll just do the same thing as we did before. Okay. Let's see. prize fight, opera. It's like 1. It's 5. Okay, so how do I find the mixed Nash equilibrium? It's the first thing I do. Put the P's and the Q's, exactly. So I'm putting the P's over here. Oh, by the way, do I need to use P and Q? Could I use Q here?
It's arbitrary, right?
Yeah, it's kind of arbitrary. I could use an X, whatever, right? Doesn't matter. Yeah? See what I'm saying? So that's another reason why you don't want to write your answer as P equals something, right? Because your P might be not the same as P, my P. You see what I'm saying? Yeah? So just, that's why it's good to translate it back. Okay. Okay, so let's do P, 1 minus P. It's just a convention to do P's there. And for person 2, I do the Q's, right? Okay, but I could have switched it around and used X's and Y's or whatever. Okay. This P equals 1, 0, 1, 0. Let's do our box diagram. Okay. Okay, I put my P's and Q's up there. Oops, well that's the answer. Okay. Let's do the stars first. That's person 1's best response. Go over here. This is what I've been doing. Okay. So say this is person 1's expected utility from doing the prize fight, and person 1's from doing the opera. Person 1's expected value from doing the prize fight is what? It's going to be a mixture of what? If person 1 does a prize fight, person 1's getting what? The 2 or the 0, yeah? Person 1 gets a 2 and probably what? Q, right? Because person 1 gets a 2 if person 2 plays prize fight, person 2 plays prize fight, probably 2. So person 1's expected value is going to be 2 times what? Q. And then sometimes person 1 gets a 0, right? It's probably what? Oh my. Yeah. If I simplify that, that becomes what? What about the opera? Person 1 plays the opera. Person 1 either gets a 0 or the 1. Person 1 gets a 0 with probability Q, right? And gets the 1 with probability what? 1 minus Q. This number is what? That's the thing. If Q is 1, which is the bigger number, prize fight or opera? Q is 1, that number is 2, that number is 0, right? Q is 1, which is the bigger number, prize fight or opera? Prize fight. If Q is 0.99, which is the bigger number, prize fight or opera? Prize fight, right? Etc., etc., etc. If Q is 0, which is the bigger number? Opera, right? And Q is 0.01, what's the bigger number? Opera still, right? At what point does the person 1 switch over? 1/3, you just set them equal, yeah? Okay. So we set those 2 things equal. I solve for it, I get the Q over here, I get 3 Q equals 1. Are you okay? Can you still hear me? I tend to kind of decrease a little bit over. I'm okay. All right. I think Q equals 1/3. Do you guys know about diaphragmatic breathing? How many people know what I'm talking about? How many people have like taken like a speech class or a drama class or singing or something? Yeah. So it's all about, if you do that, so back in the day, there was no such thing as a PA system, right? If you went to Broadway in 1920, no PA. People had to like speak and you had to hear them. So there was this whole art of how to speak, and a lot of it has to do with breathing. Just like you know that. So anyway, I have taken classes on diaphragmatic breathing. Okay, you breathe basically, you try to just breathe as much. Yeah, you breathe kind of down here. You don't gulp like this. You kind of breathe down. That's the idea. So the switchover looks like this. These are all the stars. I'm actually singing one of the UCLA choirs. I'll let you know when our choir singers. Is anybody else singing the choirs? Yay! It's fun. Okay. All right, that's the person one's best response. Okay. What about two's best response? So, what does that look like? Okay. How do I do that? Let's do two's best response. Okay, if 2 does price fight, 2's doing what? 2's getting the 1 sometimes and 0 sometimes, right? 2's getting the 1 with what probability? P, right? And you're getting the 0 with what probability? 1 minus P. This number is what? This P. If 2 plays opera, 2 is getting 0 with probability what? P. And then getting the what? 2 with probability 1 minus P. This number is what? 2 minus P. How do I find the switchover probability? I set them equal. So I get what? 3P equals 2. P equals 2. Okay, so let's do this now. Now, P equals 2/3. Okay, now if P equals 1, what's 2's best response? P equals 1, which is better? Prize fight or opera? I can barely see it. Prize fight is what? 1, and this is 0, right? If P equals 1, which is 2's best response? Prize fight or opera? Prize fight, right? So what does that correspond to here? It corresponds to this. Yeah? Does that make sense? Choosing to be prize fight or opera. Prize fight is on the left. Corresponds to if P is 0.99, which is better, prize fight or opera? Prize fight, right? This is 0.99, this is like 0.02 or something. Yeah? So P equals 0.99, prize fight is best. Okay? What if P is 0, what's best? Prize fight or opera? Opera, right? So choose this. If P equals 0.01, opera, right? Person 2 can choose anything among here. The best one is opera. At what point does person 2 switch over from prize fight to opera? Figure that out. So 2/3. Okay. What are the Nash equilibria in my little diagram? It's just a little different. This is not the swastika thing, right? Yeah. It's different because how many Nash equilibria do I have here? I have 3, right? There's 3 places of intersection. Yeah? There's this point, and this point. Okay. What does this correspond to, by the way? Is this mixed strategy Nash equilibrium? This actually just corresponds to just this, yes? Person 1's playing prize fight, 2's playing prize fight, just corresponds to this. This corresponds to prize fight, the pure strategy Nash equilibrium. This corresponds to what? Opera. Yeah? Okay, so in this case, we have 3 Nash equilibria. We have 2 pure ones and 1 mixed one. Make sense? Okay, so in this case, I have two pure Nash and one mixed strategy Nash. Okay, and that's the way I've written it down. Okay. It is also okay to write, what is it? 1/3 prize fight plus 2/3 opera, right? And then that's what 1 does, right? And then 2 does 1/3 opera. Same thing, I think, right? 1/3 prize fight plus 2/3 opera. Okay. Oops. Okay. Did I make it? I just want to make sure I didn't mess it up. No, I think I'm. Hold on. One prize fight with two, probably one place. P is 2/3, right? So it's 2/3 prize fight, 1/3 opera for 1. For person 2, it Q is 1/3, so it's prize fight. Oh yeah. Oh, I missed it. Oh yeah, this is wrong. I'm sorry. I mixed them up. Okay. Am I okay now? Yeah? Yeah, I think I'm okay. Yes?
How again did you determine whether to start your axes from p equals 1 as opposed to p equals 0?
Oh, like why did I?
Why did you go top to bottom?
Oh, okay, the reason, that's a good question. The reason is because I kind of want to keep the same sort of geometry as my original game. Okay, so if I set P to probability of prize, I want this kind of top left corner to correspond to top left corner of this game too.
But aside from the visual correlation, is there like a numerical way that we can determine whether or not to start from top or bottom?
There's no.
So we should always solve for the Nash first.
Ideally, you should look for the pure Nash equilibrium, and you look for the mixed. Then, if you want to be super careful, you would do something like this.
What if there is none though?
No mixed one.
Like no, because the reason you started from the top is because you knew that the best answer was in the upper left-hand corner. But
Right.
if there is no Nash, like in the previous problem, how do you
Right.
know where to start from?
Oh, okay. I see. I think I understand your questions. So, for example, like in the previous example we did.
Yeah.
So how do I know where to start?
Yeah, so you're starting from the bottom there. How do you know?
Okay, so if I understand you correctly, the question is not why did I set p equals 1 up there and not p equals 0 up there, right? It's
That's
clear.
what it's-
That's okay, right? The question is simply why did I start drawing the pluses
Yes.
in there? The answer is that doesn't matter. Either way is fine.
Okay.
So I just happened to work it out that way. So yeah, so let me see. Okay, so here, for example, I put those little pluses there. That's just because I said, well, if p equals 1, then that's the best response. If p equals 0, that's the best response. It doesn't matter what order I do that. Yeah. Okay. Any questions? Any questions? Okay. All right. This is often asked. I think somebody already asked it. Anyway. Did I get everything right? I don't want to make a mistake, right? 1 plus prize fight, 2/3, upper 1/3, that's this. 2 plus 1. Yeah, I think we're okay. All right. To find mixed Nash equilibrium, do I always have to write down the box diagram? The answer is no. Okay, so I'm doing this mainly to show you how it's done and why it works and all that stuff. Yeah, but once you're used to it, you can simply just do this little math here. In fact, you just can kind of forget about that. You might say, why did you teach us all that? Well, I'm trying to explain why it works, okay? But really the key is this. Okay? The key is to find this total probability and just do this. You probably did that in section already. Some people do. You don't have to do this all the time. Okay? You can just do this. No?
No, I have no idea what he was doing.
Okay. Okay. All right. The point of the box diagram is simply that mixed strategy Nash equilibrium are just regular Nash equilibrium game. Once expanded, include randomized variables. So just to remember, like from the very beginning, when we did the penalty kick thing, right? Why did we put mixed Nash equilibriums? Because there wasn't Nash equilibrium original game. Then we say, well, we got to do randomization, and people do randomize in a penalty kick. So then just do it another way. We added, we sort of expanded it.
So would you want us to list all the Nash equilibrium together or mix and pure separately?
So like I could ask, find all Nash equilibria, pure and mixed, then you'd have to write them all down. So in this case, like, you would have to write down all three. But if I ask, just find mixed, this one. Ask, find pure, this one. Okay, so, I mean, some people don't like mixed Nash equilibrium because, so in the penalty kick game, it seems pretty clear that they would be 50-50, right? That seems totally reasonable, right? But here you say, this is this game, there's two perfectly fine pure Nash equilibria. Why do I have to do this thing where people are randomizing? There seems to be no reason at all why people would randomize this game, right? And I think it's a valid reason. Some people really do not like mixed Nash equilibrium for that reason. So in fact, it's sort of sometimes it makes sense and sometimes it doesn't. Right? In this game, it seems crazy to think people will actually randomize, even though it actually is a fine Nash equilibrium. So it kind of makes you think, when is mixed Nash equilibrium reasonable, when it isn't.
So pure Nash equilibrium would not as mixed as Nash equilibrium.
Yeah. So that one would be, strictly speaking, pure. It wouldn't be mixed. Yeah. Mixed means that you're randomizing on more than one thing. Any questions? Yeah.
So when we're like writing down the answers on a test, when we're doing the pure, can we just simply say the numbers or
Yeah.
grab the numbers?
Oh, okay, that's a good question. What if I said, okay, what are the Nash equilibrium in this game? Let's calculate it. If person 2 plays A, what do I underline? 3. 2 plays B, what's 6, right? If 1 plays A, 2 plays what? 4. Person 1 plays B, what's 4? Okay, so the Nash equilibrium are going to be. Okay, so would it be okay for me to do this? Not quite, right? But why? Because it's not clear what 3, 4 I'm talking about. You see what I'm saying? Right? Yeah? So you should write your Nash equilibrium in terms of what? Yeah, the strategies, 1A, 2A. Yeah? Is that clear? You see what I'm saying? So it doesn't make sense. This is kind of wrong. Yeah? So this would be the better way. Right? That's good. Yeah? Is it clear why? Yeah? How about this? What if I just did this? Would that be correct? How many of you think it's correct? How many of you think it's not? Okay, why would it not be correct? Sloppy. Remember, go back to the definition. What's the definition? Yeah, go ahead.
Because you circle the payoffs and not what the best moves are.
That's true. Okay. However, when I circle this, does it indicate what the strategies are?
Yes.
It does. Yeah. What's the definition of Nash equilibrium?
The best strategy
Well,
given what?
Yeah, it's a strategy profile in which each person's best responding to what everyone else is doing. Like, so it's a strategy profile. It's a specification of strategy for each player, right? So why is this not a Nash equilibrium?
Except at the end.
Yeah, because it's not specifying the strategies, right? The key thing in specifying the Nash equilibrium is specifying the strategies. Okay. Is this a Nash equilibrium? Yes, I'm specifying the strategies. Okay. Now if I do this, is this correct? Does it specify the strategies?
It's technically correct.
Yes, it is. So this is correct. You would get full points with this answer. Does that make sense?
Everyone's going to be putting like arrows on them.
Right. You see why, right? See, it's writing this down is different from this. Yep. You see what I'm saying? Is it clear? Yeah. So this would be okay. But ideally you do this. Yeah.
So if you have multiple Nash equilibrium, you have zero multiple.
Yeah. That's another reason. But it's okay to say I circle the Nash equilibrium. That'd be okay. Or I wrote down the circle. All the Nash equilibria are written in purple or something. That would be okay too if you have a time. Okay, is it clear? Okay. All right. Any questions? Those are good questions. All right. Now let's review. We know how to write down a strategic form game. Okay, or a table. How do we make a prediction? Let's review. What's the first method we used? Yeah, iterative elimination of dominating strategy, strongly or weakly. Yes. Okay. Okay. What's the second method we have? So was that enough, by the way? Okay, why is this not enough? Because sometimes there's no domination, yeah? Sometimes it just doesn't work as a prediction. See? So what do we do next? Nash equilibrium. Sometimes no strategies will dominate, so we came up with Nash equilibrium. Was this enough?
No.
No, because we have like the penalty kick situation where there's no pure strategy Nash equilibrium. So then you do what? Mixed strategy Nash equilibrium. Okay? Yeah, you're done. Is this enough?
I'm guessing not.
You guess not. What do you think?
Yes.
You should ask him. It's
You
probably
ask
the
him.
reason why you're asking.
The answer is yes, we're done. Yay! Give yourself a pat on the back. In any strategic form game, there is at least one pure strategy or mixed strategy in Nash equilibrium. So once you know how to figure out these things, and we only did it in the simplest cases, 2x2. Imagine, what about a 3-person game, blah, blah, blah. There's actually one final from many years ago. I asked for a mixed strategy Nash equilibrium 3-person game. What about more complicated things? And we usually don't do those things because it gets super complicated really quickly. You start using computers and all that. So anyway, but you get an idea what a mixed strategy Nash equilibrium is in the simplest 2x2 case. Anyway, once you know how to find those things, you can find a Nash equilibrium from any game. Okay, literally 17 players, each one with 23 strategies or whatever, you'll always be able to find one. Okay? And that's a mathematical proof. John Nash proved that, the guy who was played by Russell Crowe. So that's why they call it Nash equilibrium. Okay. So that's one of the things he did. Okay. So yes, we are done. So no matter what you do, you can write down any huge complicated thing, and it will have a prediction. It will have some sort of Nash equilibrium, either mixed or pure. Okay. So you'll be mixed prediction. Yeah.
Problems on the midterms, are you gonna make us do like 17?
No. You can look at, if you look at the ones in the midterm, you can go look and see. They tend to be much more direct, and some of them are hard, but they're not like super like detailed-ish, because we're supposed to get it done in 75 minutes. So you can take a look. Yeah.
If on like the midterm or the final, if you ask us to fill in the numbers for a game and then like eliminate and find the Nash equilibrium, if we fill in like wrong numbers technically, but we do the rest accurate with the numbers, are we gonna get points off for that?
So yeah, usually in that situation, if you're asked to like on chaos, we're trying to make it so it's very, very clear how the chaos is written, so there's no arbitrary. It's going to be difficult for homework in that sense.
Oh.
Okay, so there won't be any. We'll try to eliminate that aspect as much as possible. Even though that's a fun aspect, I think what game theory is about is kind of figuring out how you feel about this. When you're actually modeling something real, that's what you have to do. But in the midterm, we will not have that. We'll try to make it super cut and dry. You can look at the old midterms and see. But to answer your question, if you do make a mistake and make a mistake in the game, you will get partial credit. You won't get through.
So are there cases where you wouldn't have a mixed strategy Nash equilibrium?
Yes, that's a good question. Okay, what kind of game in which you would not have any mixed strategy Nash equilibrium at all? So we looked at 3 games which all had so penalty kick has no pure strategy and 1 mixed strategy, right? The second, the one we did earlier today was similar. Like it was no pure strategy and 1 mixed strategy. And this game over here has 2 Nash equilibria, pure and 1 mixed. So all of them had. All of them had mixed Nash equilibrium. Some of them had pure, some of them did, but all of them had a mixed Nash equilibrium. Is there any game which has no mixed Nash equilibrium? That's a good question.
There's only one best option.
Yes. Exactly. So what would that look like?
The line.
That's true. So what would that look like in terms of this? I just tell me the
One
word.
and everything else is 0.
Huh?
1 and everything
Let's
else
see.
is
Let's
0.
check it out. Okay. This is kind of, what are the Nash equilibrium of this game? Pure strategy.
Or 182A.
Well, this one, but also, look,
One DTV.
this is also one, yes? Yeah. So this is close, but not quite it. Turns out that this might have a mixed one. Okay. But you're close, very close. What would be,
Maybe a 2.
huh?
Like negatives in the bottom.
2 or
What if I, yeah, exactly. What if I did this? What do you want to make these two? Okay.
Yeah, I mean, it doesn't really matter. As long as the bottom are negative.
Yeah, what you want is there's a word I just put it up a second ago. Yeah, exactly. I want a strongly dominated strategy. Go to something, right? You want a strongly dominated strategy. See, so something like this, right? In this case, does A strongly dominate B? Yeah, 1's better than -10, 0 is better than -10, right? For person 2, something 1's better than 0, 0 is better than -10. 1 will never play B, or 2 will never play B, right? So in this case, will there ever be a Nash equilibrium in which people sometimes play B with like property 1 or something like this? No, you're just never going to play B ever, right? It doesn't make sense. Yeah, so in this game, there's no mixed Nash equilibrium at all, right? Because you would never want to play something which is dominating, even the small problem. Make sense? So in this game, what are people going to do?
Big A.
Big A, right? Just straightforward. Yes.
If you tried to like mathematically find the mixed Nash equilibrium with that, would it just be like indeterminate or what?
No, that's a good question too. Let's think about that. Okay. Let's do that question. Okay, so let me write it over here. 1A, 1B. Okay, so this is what? 1, 1, 0, negative 10. Is that what it is? 0, 0. Oh, minus 10 zeros, right? Right? No, that's 0, 0. Negative 10, 0. Negative 10, 0. Is that what I have? So A dominates B for 1, A dominates B for 2. Is that right? Can I make this a 0 just to make it, I'll just say, okay, is that okay too? I saw dominance. All right, let's do this whole thing again. Okay. Oh, do you want? Let's do the stars and pluses. Okay, if 2 plays A all the time, what is 1 going to do? A or B? A, right? If 2 plays B all the time, that is Q equals 0. If Q is 0, 2 is playing B all the time, what is 1 going to do? 0, 0 minus 10. A, right? If Q is 0.01, what's 1 going to do? In fact, what is 1 always going to do? Play A all the time, right? So the best response looks like this. You see what I'm saying? Right? It never switches because person 1 never wants to play B. Yeah? Similarly for person 2, if 1 plays A, what is 2 going to do? Play A, right? So there's a plus there. If person 1 plays B, what is 2 going to do? Play A also all the time. So in fact, person 2 wants to play A all the time. So this is what the picture looks like. Yes? Okay. So what's the only Nash equilibrium? Yeah, this stuff here, right? Where they both play A all the time. So if you get Nash equilibrium, it's going to be. Okay? Right? Now I'm going to do something which don't get too confused by this. But let's see, I did use a box diagram. Okay? Let's say I just did it the fast way like I just said you could do. Okay, so how do I do that? I don't do the box. Okay. I just look at the expected value of person 1 from playing A, expected value of person 1 from playing B. Okay? If 1 plays A, 1 gets what? Either a 1 or a 0, right? So you get for someone who makes one with a probability what? Q, right? And 0 with probability what? 1 minus Q. This number as well. The person one plays B, they get what? 0 with probability Q. And then what? Negative 10 with probability 1 minus. What's this number equal to? Negative 10 plus 10Q. How do I find the switchover probability? Set them equal. So I solve, I get what? I'm going to put my 10 over this side, I get 10 equals 9Q, right? So then I get 2 equals 10 over 9. Okay? So I'm going to write this over here. 10 over 9. What's this number here? 1 minus 10 over 9 is what?
Is it greater than 1?
Yeah, okay, so you see the problem, right? Okay, it's actually a negative 9, right? Why does this not make sense?
Because probability.
Yeah, probably it's getting bigger than 1. This doesn't make sense at all. Yeah? I'm finding for the switchover probability, but we just did with the thing, it doesn't switch over, right? So I shouldn't be able to find it in some sense, yes? Okay? So like, whenever you do something like this and you see that your number probability is like bigger than 1 or less than 0, you know there's an issue. And that issue is that there is no switchover probability. And probably you have something which is, you have strong dominance, essentially. Okay? Does that make sense? And so, just like, so, remember the original question was, is there a game with no mixed strategy Nash equilibrium? This is one of those, right? And if I were to solve for it this way, I could kind of see it just by this, right? I get an answer which doesn't make sense, then I realize, when I solve for the mixed strategy Nash equilibrium, I get an answer which doesn't make sense, so therefore there must be no mixed strategy Nash equilibrium. Okay? Does that make sense? Any questions? All right. Anyway, so we're kind of done with this little part of the class. Okay, this is like one little topic. Okay, so you actually know a lot in the sense that you know how to write down a game. Okay, players actually playoffs, and you know how to make a prediction. Okay, so you can actually use this anytime you want to, like in your life or whatever. You can say, I'm in this kind of weird situation. What's going on? You think about it. The first step is who the players are. What their actions were the payoffs, and you can sort of just write it down and just figure it out. I mean, you can use it in another class, you can use it in daily life. When you get a job, you can think about this stuff. It's just like a useful tool. You can just kind of figure this stuff out. That's what this is all about. Okay. Yes.
Can you do mixed Nash for 2x3?
Right now?
Isn't there
Huh? What?
a more problem like that?
Is there? Oh yeah. Let's talk about that. Okay. Oh yeah, so this one, number 9 is our chunk? Yeah.
Doesn't it have to get rid of it though?
Yeah, so what I'm asking you to do here is first eliminate stuff. So when you can eliminate it, then you should be able to get it to a 2x2. Yeah. I think also that the battleship one is like that too. You can, with this battleship one, I think there's 4 spaces and you should be able to eliminate stuff using weak dominance. Yeah.
Are there instances in which it will be a 3x3, it can't be eliminated, and we have to do
We'll try not to ask that question. But I could do it next class if you want to do that. Yeah.
okay.
Yeah, probably. We'll see. I mean, I don't want to rule stuff out, but there won't be something crazily difficult on the midterm. Just look at the old midterms, you'll see. Any questions? Huh? Oh, 3%. We'll do that next time. Yeah. Okay. All right. Hey, guys, I think we have 8 minutes, no? Thanks. Because I want to do this next thing. I just want to make sure. Yeah?
I just wanna know if you go through the last problem.
On the Homer?
Yeah.
Is that the battleship one? That's what we were just talking about. Do you want me to talk about it? Do you want me to talk the battleship one? Okay. I kind of want to. Well, let me just end my lecture a little bit, then I'll do that. Okay? Does that make sense? Okay. So, let me just pick off what I want to do. So again, we're okay. So we're done with this thing. Okay. One thing we have, however, implicitly assumed throughout all this is that people choose independently. Okay? So like when you play chess or checkers, somebody makes a move and then you see it and then respond to it. Okay? None of the things we have that quality, right? Here people just choose. Okay, so it's an assumption which is implicit, which is kind of like simultaneous. Okay? So that you don't choose your actions in response to the actions of others. People choose their actions simultaneously. But in many situations, you can respond to the actions of others. So that's the next thing we'll be doing. Okay? And people we'll look at how people move in sequence. Okay? And there's a different model for this. Okay. So anyway, we'll talk about next time. The model for that will be called an extensive form game or a tree. So we have models of strategic form games, your tables. These will be extensive form games. Okay, let's do the battleship one. How many people have tried this? Is it okay? Does it work out? Yeah, it should work out. Okay, let's see. All right, so there's 4 spaces. Well, if you look at the old homework, there's tons and tons of battleship questions, by the way. I just love these battleship questions. So like the old finals. Okay, anyway. So there's 1, 2, 3, and 4, right? So it's like a little, your board looks like this. Okay. All right. So if you're person 1, you can fire at what? 1, 2, 3, or 4, right? If you're person 2, you place the ship, right? So where are your possibilities? 1 and 2. 2 and 3, and 3 and 4, right? This corresponds to placing the ship at this, this. Does that make sense? Yeah. These are the spaces. This is like that, that, that. Okay, what goes in here? So this is where 1 wins, yeah? The attacker wins, so it should be 1, 0. How about this? 0, 1, I think, right? 0, 1. Makes sense where 1 means, so this means person 2 was not hit. Yeah? Makes sense? You can use -1, 2, it doesn't matter. Okay, how about here? This is also 1, 0. This is 1, 0, 0, 1. Is it clear how we got that? This is like straight from the lecture before, right? Is it clear? Yeah.
In your lecture slides for the previous lectures, there was 5, 0. Is that allowed?
Was it 5? No, what done?
Yes, 5, 0. Is that okay?
5, 0?
Yeah, putting 5 instead of 1.
5?
Instead of 1, 0, 5, 0.
Oh, yeah. Let's just do 1, 0, just as easier. Do you want me to do 5? I'll do 5.
No.
Okay. How about this? I think this is 0, 1, right?
1, 0.
1, 0, 1, 0. And this is what? Yes?
Mm-hmm.
Okay. Is anything dominated? Weak way or strong way? Yeah. Well, for person 1, yeah. 2 dominates 1, right? There's a tie here and bigger in the tie here, right? Does that make sense? Okay, so in other words, if you're person 1, you shouldn't fire into 1 because you can always do at least as well firing into 2. See why, right? Anytime you would have won by firing into 1, you'll win by firing into 2, and sometimes more often, yes? Okay, so I'm going to get rid of this. So I'll do that.
3 dominates 4.
So 1, 2 weakly dominates. 2 weakly dominates 1. And 3 weakly dominates 4, right? Tie, 1 better than 3. Is it clear? 3 weakly dominates 4. Okay, now what? Anything dominated?
3, 4 weekly dominates 2, 3.
Yeah. Now in this smaller game, 3, 4 weakly dominates 2, 3, right? This is 1's better than 0, and there's a tie here. Yeah? Make sense? So what do you think about this is, I'll call that. Third step. 3, 4, weakly dominates. Does this make sense? Remember? So like, if you're the attacker, you don't want to attack in the corners, and therefore if you're the defender, you want to put your ship in the corners. Yeah? Knowing that the attacker will never do 1 or 4, they'll always do 2 or 3. Therefore, you don't want to put your ship in 2, 3. Does this make sense? Okay, so now do I have anything left? No, I think this is done, right? So now if I write this as a separate game, I have okay, so 1 can either do what, 2 or 3? And 2 does either what? 1, 2, or 3, 4. And then I write this as, this is what's left over, yeah? Is there any Nash in this game? Pure. This is the same game as what? D-Day thing, matching pennies, Princess Bride, right? Okay, so how do I solve for this? Mixed, right? Yeah. Mixed. So I do the. Huh?
Aren't there also pure Nash
I don't think there's a pure with pure, right? It's like, is this the situation? Huh? Yeah, exactly. Same as penalty. Okay, so then I do the whole thing. You'll find it mixed. That's.
Yeah.
Okay, all right.
Have you ever used one of these bottles before? They give them out of some of the cafes for like $8. And they're like insulated bottles. I put coffee in them last night. It's like still really hot.
Usually $20.
Yeah, hydro plastic.
Get in the cafe. Yeah.
Who's first? So I just have a question. So I noticed how we strongly or we weakly dominated the first row, right?
Right.
I thought right after you do that, you need to player 2 then.
You could do it that way, yeah.
Okay. And then, but it doesn't matter, does it?
Well, let's see what happens. If I just did 1,
It's like on
either one would be okay. You might get a like say if I go with 1, then I can get anything because this is on for 2. So I get rid of this one, and then I go to the 2 and say, well, I can get it done. So maybe I'll go back and see which one. It would just be as long as you're super clear. Sometimes you might ask me like eliminate as much as possible using domination. You don't want to be trying to try lots of tricks. Yeah.
Okay, I see. Well, that's my question. Thank you.
Hey,
Hi, I had a question. So I was getting it the whole time, and then like halfway through, I was like, I am lost.
No problem.
So it was actually, so right here, for when you're writing this down, you're not writing the Nash equilibriums, right? You're just writing the probability of each option.
No, that is the Nash equilibrium. It's a specific Nash equilibrium
It's just a
specification.
specific, but I mean, like, because the way we're writing it is it's like 1 plays prize fight with probability 2/3.
Right.
Or opera with probability 1/3. So how does that make a Nash
Oh,
equilibrium?
it's not an or.
It's not. Well,
that's why it's kind of strange. It's like just like in the penalty kick thing. My strategy is playing east of half, west of half. That's my strategy. And so suddenly here, I will end up doing prize fight or opera, but my strategy is specification of what I'm doing, and that is playing prize fight if there's opera upon me. Make sense?
Yes, it makes sense. Yeah.
It's not. That's.
It's like it's just. I think my problem is that it's not written like the other way.
Yeah, right.
Written
Exactly.
in the Nash. So like when I look at it, it doesn't. I understand what's saying, but I don't understand what it's saying at the same time.
Oh, it's just. Okay. One way to think about it is. Going back to the penalty kick example, you could simply say there's no Nash equilibrium. Right? We don't know whether people are going to east or west, which is true. But then we think, oh, can I say something more? Then we open the door to a whole new set of strategies. You don't have to open that door. Some people don't like opening that door.
Okay.
But maybe say, okay, well, it seems people are randomizing, so therefore we have to think about randomized strategies. What would that mean?
Okay.
The randomized strategy would be a specification of probability of specifying which strategy you're playing with what probability.
Okay.
And once you have that, then it's just a strategy like anything else. It's just a little object, and it has a weirder interpretation. But it's just like remember when we did the 50-50 strategy? That's what you can think about.
Okay. It's okay. Okay.
Yeah.
Thank you.
Sure.
I have a couple of questions. Just for an example, when we're trying to read or like trying to plot everything, so when Q equals 0, that's assuming that it's over here, right? So P would want to be 1. So would you, because the payoff is better when P is
Oh, Q is 0.
Q is 0.
This was over here all the time.
Yeah, so
P would want to do 4 instead of 0. Yes,
yeah,
so 1.
so it'd be 1. So then you'd start it on this axis,
Right.
right?
So when Q is 0,
okay.
person 1 is choosing among. Hold on.
When Q is 0, person 1 is choosing between P and.
Oh, this looks wrong.
Oh.
If Q is 0, P is choosing among all the numbers in here.
Oh yeah.
So we'd have to choose
You're good.
1.
Yeah.
So it would be the star should be up here. That's what I think. That's yeah. It's these are the stars. I think.
Yeah. That's
so
what I
that's
did.
why the star is up there.
Okay. And
When
then
Q is 0.99, it's similar. The person would want to play
would
library,
still want to.
and so therefore the star is still up there.
Yeah, up until the point in which it switches over.
Yeah,
So then, but like in an alternative situation, and this one when Q is 0, P would also want to be 0, correct?
Right.
And so that's why when Q is 0, P would be 0.
Right,
So you
that's where we're
start down
starting.
there.
Exactly.
Okay. And then I have a couple questions on the homework. For number 2, it tells us to like read an article and then make the situation described and set it up as a game.
Sure.
And the book was about, or the article was about like a man who was falsely accused of sexual assault by 3 girls. So who are the 2 players in that?
You have to, that's what makes it a little interesting. I don't know.
Okay.
Some people always ask me about that. I try to. To me, it's the. I mean, what do you think? It's the interesting thing about the game.
I was thinking. So the 2 that I could think of is like if you